This iPhone 13 Pro Max was sent by a fellow technician. Let's take a look at the phone. It's clear the back glass has been replaced. The system has been flashed. Without the baseband, the phone can't be activated. Upon close inspection, the phone doesn't show any obvious deformation. iPhones easily lose baseband, and this issue has persisted for years. If this phone can't be fixed, the technician might end up losing a month's rent. After opening it up, we can see from the fingerprints inside that it has indeed been repaired before. We remove the screen and carefully protect the front true depth projector. Then, we take out the motherboard. The shield sticker and the foam around the internal connector have been removed from the motherboard, but the motherboard is not deformed. It's clear the board has been separated before. The dual-layer motherboard design is one of the reasons iPhones easily lose baseband. Let's separate the motherboard layers. Some people quietly watch the video, but secretly like, comment, share, and follow. People like that are truly adorable. The lower motherboard is responsible for the baseband. Let's take a look. The Qualcomm X60 baseband chip has been worked on. The RF chip has also been touched, but the baseband power chip has not been touched. Any damage to these three chips can cause the baseband to fail. Let's remove the baseband chip and see what's underneath. The solder points are full and perfectly placed. It looks like the previous technician did a great job. We removed the RF chip to check as well. No issues there. Now, we can only hope the untouched baseband power chip is the problem. It might have become poorly soldered after a drop. We remove it and reinstall it. We clean the solder pads of all three chips on the motherboard. Then, we apply new solder to the chips and install them back onto the board. Since this is a dual-layer motherboard, we can't test the baseband's working voltage after reassembly, so we can only test the resistance on the power circuits before reassembling the layers. Upon testing, we found an issue. There are two short circuits on the baseband circuit. Let's check the schematics. The short circuits are connected to both the X60 baseband CPU and the baseband power chip. This means either of these two chips might be causing the short circuit. Since the X60 baseband CPU is encrypted and cannot be replaced, we will first remove it. We'll use a process of elimination to see which chip is faulty. Let's hope the power chip is the problem. After removing the baseband CPU, we measure again. The short circuit is gone. Well, this is awkward. Could the short circuit be inside the baseband CPU? Let's measure the corresponding pins on the baseband CPU. It turns out the encrypted chip is indeed short-circuited. Unfortunately, this can't be fixed. Sadly, we have no choice but to put everything back together. We apply new solder and reassemble the upper and lower layers of the motherboard. Then, we install the motherboard back into the case and reconnect the screen. Not giving up, we power it on and test again. As expected, there is still no baseband. Let's flash the system and try again. Just in case we get lucky, after flashing the phone, the baseband is still missing. That's it for the repair. We reassemble and restore the phone. Unfortunately, we couldn't help this fellow technician. Phone repair is like this. Some hidden issues are impossible to foresee. In the end, I hope the technician can resolve this and minimize their losses.